Welcome, everyone. We're happy to have you here today, everyone in person, as well as those of you who are joining us via Zoom. Definitely appreciate you guys coming out today. We have an awesome presentation today by GeoComm. And for that, I'm going to go ahead and let Ryan introduce himself.
All right, well, good afternoon. So I'll start with some introductions here, as John said. So I'm Ryan Thomas. I'm our VP of Engineering and Technology from GeoComm. Let Chris introduce himself.
Yeah, hi, I'm Chris Nelson. I'm a software architect at GeoComm. I've been there a little over 2 years, and I'm actually a St. Cloud State graduate. Graduated back in 2002, I believe, in the computer science program.
There you go. All right, let's get started. So who is GeoComm? And you've maybe seen our sign downtown. We're right downtown, right on just kind of across from Herbert's and Gerbert's, if you frequent that. And then we've been around since 1995. We're a software and solutions provider for public safety. So GeoComm, we think of ourselves as a nationwide public safety location intelligence provider. We have software for 911 call and incident mapping. We have software that routes 911 calls. So it'll actually find which call center based on the address of the caller to route the call to. And we have software that helps with GIS data management for 911 and public safety, as well as professional services doing cleanup of that 911 data. So we're here to talk about GeoComm, and specifically GeoComm and our use of AWS at GeoComm. This past year, GeoComm became an AWS partner. Earlier this year, we became a technology partner, and not too recent, fairly recent, maybe in the last month and a half, we became a public sector partner. And public sector is anything government and education. And so we are really excited to be a public sector partner. Being a public sector partner really showcases our dedication to government and all of the compliances that go around government and cloud hosting. So GeoComm decided to leverage AWS simply because we needed to move away from on-premise software installation package software and get into a cloud-hosted multi-tenant software as a service solution provider offering. So we looked at the various cloud hosting providers that were out there. AWS had a strong presence in government. They had one of the better availability and uptime capabilities of all the cloud providers, as well as they had deep roots with another partner that we're engaged with, which is Esri. So if you're familiar with GIS and Esri, AWS and Esri had a long-standing relationship. So we chose to go with AWS to build out our cloud-hosted solutions. Enter Chris and his journey with GeoComm 2 years ago. We really started digging into all of the AWS capabilities, specifically being able to scale large workloads, being able to do serverless architectures, as well as offer solutions to government that met a lot of the compliances that government needed. One of the things we found with AWS is they had a service, or really data centers called GovCloud. So GovCloud is really some data centers that AWS has gone the extra mile to make sure that they meet the compliances that government needs from a security and facilities perspective. So they have multiple regions, that's what AWS calls them, multiple groups of data centers that meet those stringent guidelines. So from fault tolerance to you know, the various compliances that fall under government. We're able to deploy sensitive workloads to those environments. And most specifically, we're able to deploy workloads that meet CJIS regulations. So CJIS is Criminal Justice Information Systems. There's data in public safety, specifically law enforcement, that's criminal justice information. And sometimes those types of things or that data could end up in some of our technology, the solutions that we offer. So we're actually running workloads for some of our solutions in GovCloud. Now I'm going to take some time and go through some of the services and technologies that we're using in AWS. I do want to open this up to questions all along, so feel free to jump in and ask questions if you have them. John, I think, is kind of running point on questions, and he'll jump in and interrupt us. Feel free. And if you want to go really technical, Chris is here, and he can go deep and go technical on some of these capabilities that we leverage. So the first thing that we use that I think is really interesting with AWS is their serverless capabilities. So maybe you're familiar with Lambda, maybe not. So Lambda is really AWS's, call it functional services. So you can run code without the need for servers. So we're able to deploy code into Lambdas. And anytime we want to call that particular function, we can just run that Lambda and it gets spun up and it runs and then it shuts down when it's done. It supports multiple languages, and you can see the languages here, many that we use at GeoComm. But I think most importantly is it's serverless. So we only pay for what we use. So at each invocation or each request, it counts. And then the duration of that request, we only get charged for that at GeoComm. So we're not actually paying for a server running various libraries that then need to have that server compute always active and that memory always running. So we're able to really reduce the costs of our deployments. One of the projects that Chris is actively architecting using all those backend APIs are heavily using Lambdas. So anything else to add on that, Chris?
The only other thing to maybe add would be when we deploy, for example, like Ryan mentioned, APIs, we package our code up. And in our case, many of our APIs are actually .NET Core, C#, because we can use a lot of different languages there. But we package it up and deploy it out to AWS. But we also deploy some infrastructure configuration. So a Lambda is almost like a container. We drop our code in and say, okay, AWS, you're really good at running servers and functionality. We trust you. Run our code to the best ability. And so, but when we deploy, there's still some configuration to certain settings in Lambdas, and we kind of deploy those settings at the same time, and that would fall under the category as infrastructure as code. So we don't set up individual environments manually. We actually automate that through deployment, so that when we have a dev environment, test environment, production environment, we're confident that it has the same configuration in all those environments. That was one other thing to maybe add to that.
Thanks, Chris. So how do we connect to all of our Lambdas or our backend code? AWS has a service called API Gateway, and we use that to interact with those backend services. So it allows us to protect our RESTful APIs. So we're using REST, and those requests are JSON web tokens or JWTs that are passed in an HTTP header. This also gives us the ability to throttle. So we have an example here I can kind of highlight, but it lets us control how many requests we want to come into those APIs. In the case here, it could be, there's some garbage request that's super buggy, and it's maybe putting a high load on that API, and it's just overwhelming it. So we can throttle those number of requests, and that gives us a lot of flexibility shutting that off before it actually does damage to the application or creates some performance problem for us. Another thing that it does is it allows us to track the requests. So by having interactions through API Gateway, it really lets us understand, how much is a tenant maybe using that. So keep in mind that in 911, specifically our applications, we're often being connected to by customers, and we maybe want to see how much that specific customer is requesting our applications. And I believe some of that stuff is done through, we can do other services. We can port that information off to get some deeper analytics on the requests. I'll let Chris add any color or anything you want to share on that.
Yeah, I think sometimes this is a good topic too, as far as when you have APIs exposed to the internet and you have the backing of a AWS cloud environment. You don't have infinite capacity for compute and database, but you have very, very large. You can scale very quickly, which is great, but you still need to protect yourself from denial of service type attacks, or in this example, buggy software. Some client that's calling our APIs is just hitting us hundreds of times a second when it should be only hitting us a couple times a second, for example. So we might be able to scale quickly in the back end, but we don't want to in those cases. We know that's not normal traffic. And the flip side of serverless technology, like Ryan mentioned, is we pay per use. So we need to protect GeoComm from outrageous costs of bad code or denial of service attacks coming in. So it's very important to have something like an API gateway kind of blocking those right away before they get back to your back-end processing.
We have a pretty wide variety of different skill levels. I mean, we have freshmen who might be attending today. Could you just talk really briefly about what exactly APIs are, and maybe a little bit about what RESTful APIs are?
Sure. Yeah. So an API is an application program interface, is what it stands for. And RESTful APIs are, it's basically a way to expose an HTTP endpoint. So when you go to a browser and browse to a website, you got HTTP up in your browser. It's basically using that same protocol, but at a programmatic level. So there might be a client application that says, you know what, GeoComm, I'm going to send 911 calls to your API so that it will show up in our web-based cloud-hosted product. So that's one of our real use cases that we have. So what the client-side developer, meaning the developer from that's going to be calling our API, they would be writing code to basically construct an HTTP request, and we would let them know through documentation, hey, you need to pass a JSON payload that looks a certain way to our HTTP endpoint. So that's a way to programmatically, for example, ingest data into our platform.
Yeah. I was hoping on myself, Lambda, is it local, or where is it? Is it other? So a question about where is the actual Lambda located?
Yeah, so when the typical developer experience would be, you start developing locally, whether using, in our case, Visual Studio, because we're using .NET Core, or if you're Python, whatever your environment is, you still would start running locally or develop locally, run local tests, unit tests. But when it's time to run out in the cloud environment, that's when we would build or compile our code in the case of .NET and deploy it out to Lambda that's running, in that case, it'd be running in AWS. So once you deploy your code out to AWS, you might say, sure, yeah, it ran great locally on my machine, but obviously you need to test it in the real world environment. What we do is we call it the dev environment in AWS. So whenever somebody checks in code, it automatically deploys their application. So let's say it's an API that they're working on. It deploys it out to the dev AWS environment. So it's the real world environment. Remember, we have dev environment, we have a test environment, production. So it's a real world AWS environment. And from there, what they can do is use tools locally to trigger that API out just in the dev environment with test data and maybe what we'll do is look at logs and things to verify that the request did what we expected to do. So Lambdas don't run locally. There are emulators and things to try to run like inside of a Lambda environment locally. Typically, people don't do that. It's run your code locally, test it best you can, then deploy it. Don't try to mimic basically the cloud environment on your local machine. Deploy it out to a dev environment in AWS and then do your integration tests.
Yeah. So Lambda is a virtual server. The question was, so Lambda is a virtual machine on a server?
Under the covers, it actually is like I think they call it a micro virtual machine. And this is the power, this is AWS, right? This is AWS and basically invented this way to say, give me your code, package your code up in a package, whether it's a zip file or whatever. We'll store it in our storage up in AWS. Like they have a way to have a file storage that's very, very fast. And then what you can do then is when a request, picture an API sitting there waiting for some work, right? We're saying, hey, wait, I'm waiting for a 911 call to be sent to me. As soon as that 911 call is sent to our API gateway, what API gateway does, and this is all part of the AWS environment, we can tell API gateway, hey, trigger this Lambda that we know we have this code sitting in this AWS file system, right? The request comes in, API gateway says, okay, I'm going to trigger this Lambda. Under the covers, what AWS is doing is actually grabbing that code, spinning it up in this micro virtual machine, and then executing it. And it does this all within sub-second, request time. So it's pretty amazing. And what that gives you is this stateless way to scale very, very quickly. So you can picture if multiple requests are coming in, it's spinning up these little Lambdas on AWS platform. So you're not dealing with an individual server necessarily. It's a very virtualized environment that spins up very quickly and also shuts off very quickly.
And then what do you use to like spin up your dev environments? Like a EC2 or?
Question was, what do you use to spin up your dev environments?
Like
our dev, like our local dev environments on our like the developer's machine?
Yes.
Okay. So in our case with Visual, we use Visual Studio in the case of .NET Core and C#. So there's actually, AWS provides, for any of these languages we see here, they'll provide toolkits and additional functionality that you can put right in your IDE, which is Visual Studio is the IDE for .NET Core, or VS Code is another very popular one out there. So they'll actually allow you to install a toolkit that will make it even easier to run very similar, like you run your Lambda, that's be very similar to the cloud environment. It won't be identical, but it makes it really easy to write code, test locally, and then deploy out to AWS. So the key is when you're running locally, you're still just testing your logic, testing your code. The only difference is when you deploy to AWS, something else is triggering that code. When you run in Visual Studio, you can still hit F5, or a developer that uses Visual Studio knows F5 is like starts it up and runs, and you can put breakpoints in your code. So it doesn't really, the fact that we're hosting up in Lambda or in AWS doesn't really change the developer experience much from that perspective.
Did that answer your question?
Great questions. Awesome. All right. So we talked about Lambdas, we talked about API Gateway, and next I'm going to talk about another service that AWS has. It does get a little deeper here, and we can talk about messages and message queuing, but we process various operations, the things that are happening in the application using queues and messages. So we rely on a messaging service or a queuing service in this case, simple queue service or SQS, which AWS has as a service. Keep in mind these services are pre-built by AWS. We have management tools that just enable those, and we can connect those to our applications. So we're not firing up an EC2 instance, which is like a virtual server. We're using services that were pre-built by Amazon, and we just manage those and enable those. So in this case, this is a queuing service, and it gives us tons of scale. We don't have to try and install some queuing service on an EC2 instance, but we could rely on this, what we call event-driven architectures. So these are things that trigger other things, right? If something happens, this needs to happen. It allows us to take those messages and put them in queues. And I'll let Chris go into more detail on how we're taking advantage of that. And then it lets us provide this highly scalable environment. And we've got loosely coupled. So, and that's another kind of idea of how to build things, right? So you want to keep things decoupled so you can scale those things. So you're reducing the points of failure and this massive thing that can get too out of control. But the concept here of the SQS keeps things decoupled, it allows them to scale, and then it really allows us the ability to use retry logic in our platform. And there's some reference here to dead letter queues, and I can let Chris go into some of those benefits, but we use SQS quite a bit in our GeoComm Maps solution.
Yeah, I could explain one particular use case. I'll kind of keep using that notion of a 911 call. So a 911 call message, right, will be sent to our API. So now we say, okay, and if you were to open it up, it's just a JSON file. It might have things like the phone number, maybe the address of the cell tower that call came through, or the address of the landline. It's gonna have some metadata, some information in there. So we want to be able to accept those calls quickly. And you got to remember, it's a multi-tenant platform. So that means we're going to be getting calls from all kinds of different customers all the time. So we want it we want really high uptime and availability. And once we get that call, we're going to do things with it. We're going to, I would kind of say, enrich the data, right? So we're going to get a 911 call come in. We might want to connect to a third-party partner that will give us more information about that caller, about that phone number and who that is. Maybe it's even potentially health information, other types of information that we can package up and kind of grow that message and then display it on our web application eventually, which is used by a 911 dispatcher. So if you think of that flow, when it comes in, we come into our 911, our call API, and we may initially just drop it on a queue. That API might not be doing much other than take that message, put it on the queue. And then we'll have a back-end process that will automatically get triggered, another Lambda that says, oh, a message showed up on this queue. I'm gonna wake up, I'm gonna grab this message. Okay, I see it's a 911 call. I'm gonna call a third-party API. So now we're making an outbound request, and we don't know how reliable that third-party API is. Maybe they're down, right? Maybe they're doing some maintenance and they're offline for a couple minutes. That'd be worst case scenario. We don't want to block other calls coming in while that one external resource is down. So what queues give us is the ability to stay up, stay alive. Now we could pull a message out the queue, try calling some external service. If they're down, what we could do is put the message back on the queue, try again 5 seconds later or 10 seconds later, or however we determine for that business case it makes sense. Now, eventually, we might say there might be a scenario where we can't process this data. Someone sent us bad data, or external dependency isn't allowing us to process this any further. That's when at some point we have to give up, and that's what a dead letter queue is. We say, okay, we tried 10 times, we are not getting anywhere. Let's drop this, just move the message into a dead letter queue. And the nice thing about that, and that's a very common pattern. It's nothing special about AWS, but AWS makes it easy for us to kind of connect the dead letter queue to our real queue, and then we can do things like monitor that dead letter queue. Let somebody be alerted, say, hey, there's a bunch of messages showing up, something's going wrong, where we can then further investigate.
Thanks, Chris. Questions?
So what form does information going into the queue take, and what form does it take exiting the queue? So the question is, what form does information take going into the queue, and what form does it take exiting the queue?
Yeah, I mean, it's all JSON as far as the data format, and it's a format that, as far as like what fields and what is in that JSON, it's completely up to us as the engineering team building our code. So we're we're going to know ahead of time if we're looking at, if we have a Lambda that's going to do, for example, additional enriching of a 911 call, that Lambda sitting there waiting for a particular queue to have a message in it. That Lambda will know and expect a certain JSON format. That's what's getting passed around under the covers. Now, as far as our application code, you're not going to be working with JSON. It's going to serialize it and deserialize it automatically into a typed object in the case of C#. So it makes it very easy to work with.
You want to explain JSON, Chris?
Oh, yeah. I maybe should explain that. So that's the JavaScript format, similar to XML. Some of you have maybe worked with XML. It's just a structured way to represent data. So JSON is the JavaScript object notation, I think is what it stands for, which is very, very popular now. XML, like back when I graduated college, XML was being used everywhere. It still is used, but we would definitely work with JSON, which is it's similar to XML. It's just a more lightweight way to move data around.
Yeah. My question is, when does public access and the public have direct access to you, or is it and you pass it into the call? When does access? I'm assuming you mean by like the client apps. Yeah, client. When does the client no longer have access to all of what's going on back end? So when does the client no longer have access to the information which they send off to you guys?
Well, if you're a client application calling our APIs, everything I kind of just described, like this queuing and everything, that's all like a black box. They would have no idea what's going on, whether we have queues or not. If you're a client application and you send a message to our call API, like a 911 call message, that's it. You don't know what it's a black hole to you. You just know that you sent it, we received it. What we will do is our API will return back a status code of success. In this case, it's a HTTP 200. That's like a standard status code. At that point, it's now in our platform. So the way you kind of could think of how this platform works is, at the same time, there's 911 dispatchers that have a web application up in front of them. And if there's a process sending these 911 calls to our API within less than a second, often it's less than a second, that message will be pushed out to the web client of a dispatcher. So if you're a local county dispatcher, you'll then see a map and the location of the caller and some additional information. So the idea is ultimately to get information into the hands of just 911 dispatchers. Did that answer your question?
Yeah, but so yes. It starts out as a call, and I get the next one. It starts out, so sort of the flow of the call is, it starts out as a call, then it becomes a HTTP GET, and then it turns into a JSON in your system.
Yeah, that's right. When it's flowing through the system, you could think of it as it's a JSON message with some information about the call. And eventually that's going to be consumed by a web application, which will then give a nice graphical display of that information, whether it's a dot, it'll be a dot on the map, it'll be some additional information on the left side of the screen, things like the caller's name, the phone number, other additional data that we might be capturing too.
Okay. Do you have any questions from the Zoom participant? Take none. Give me one. Sorry.
Okay, so that kind of sums up SQS. So some of the data that we get, and Chris mentioned, the caller data, incident data, this data is real time. And we needed a way to actually work with that real-time data. So we leveraged AWS's DynamoDB. It allows us to store real-time data quickly allows that to scale. And if you're familiar with databases, and maybe some of you are just learning databases, there's a few different types of databases. There's relational databases, which are great for analysis. They allow you to join data. They're not as great for real-time data. And this is where NoSQL or like these file-based databases, or in the case of like Dynamo, we can use that and it can scale really well for us. The configuration complexity is reduced. So we really don't have a lot. We still have to configure stuff. We don't have a lot. Don't have to build really complex configs. And then I think another key point is we're, again, getting away from the relational databases and getting the performance out of a NoSQL database. There's a initialization here of OLTP, which is online transactional processing. I'll let Chris go a little deeper with that.
Yeah, yeah. So DynamoDB, like Ryan mentioned, it is also a managed service, so it kind of falls under that serverless terminology. Now, obviously, there's servers under the covers. The point is, though, we don't have to worry about it. Relational databases are, if you haven't worked with them before, they break data up into tables, and then you can write these SQL queries and join a bunch of tables together and do a lot of kind of ad hoc queries, like kind of asking your data questions and any kind of question you can think of. So it's really great for reporting and things like that. It's not really great for data that expands and grows really quick, because those queries, the more joins you have involved, the more rows you have in a table, it can just bog down your system quickly. That's why NoSQL databases, it's basically any database that's not any database, but primarily databases that aren't relational databases, like a SQL Server or Postgres. Those would be called relational databases. Dynamo's AWS's implementation of a NoSQL database, and what the advantage is there is we can just pump it full of data, gigabytes and gigabytes, terabytes of data, and we're not going to lose query performance. That's almost like unheard of. You can't do that as a relational database, but we can grow and grow, and we don't have to manage clusters of servers. We don't have to worry about re-indexing or optimizing queries. It's going to grow, and as it grows, we're still going to continue to get very, very fast query times. But like anything in engineering that you'll learn, there's trade-offs. The trade-offs is you kind of have to know the handful of ways that you're going to query your data ahead of time when you're building out DynamoDB. You can't sit back and write queries, ad hoc queries, and think of new ways like, oh, I want to join this data and this data just on the fly, that you can do with relational databases. So that's the trade-off, and that's why we use it for the online transactional processing. I mean, as real live data is coming in, we're flowing it through our system, we'll use DynamoDB, but then we'll store it longer term in a more of a relational, potentially relational type of database that we could do more reporting or analytics, that kind of thing. DynamoDB is not the tool to use for analytics and reporting.
So, yeah, any questions?
Yep, you got one.
So whose server real estate are they using? Like, what company are they working through? What company are they using for all that?
So all these services with the AWS, these would all be on Amazon's servers. You're paying Amazon basically some amount each month, and all these things will be billed to your account, correct?
Yeah. Correct. So we have multiple accounts. So you, as an AWS customer, we create an account. That account gives us access to use all of these services, and there's hundreds of different services for all kinds of stuff. And then as you turn them on or use them, you get billed monthly for those. You can do things like reserving things, and isn't as popular with some of the serverless stuff. But so as we use and consume those services, we get billed for those. We have a full management council that lets us then have access to all that, so we can turn things and turn dials and things like that. So the servers are Amazon servers. So actually Amazon, you know, any of these, there's a lot of virtualization in this, but they have their own virtualization. They have their own servers that they build. They have hundreds of data centers around the world. And then they turn around and they clump all those data centers together in what they call availability zones. And then they clump those availability zones in what they call regions. So the scaling and their ability to do redundancy is pretty powerful. That was my nickel tour of AWS.
Yeah. So what database do they use for analytics?
So the question is, what database do you use for analytics?
We've landed on PostgreSQL, or you sometimes heard it as Postgres. It's a SQL-based relational database that's open source, and it has probably the highest amount of contributing for an open source project of anything out there. Amazon actually has taken it and made their own Postgres-based capabilities. So in Amazon, they call it RDS. It's a service that you can use, and it gives you like a managed service of databases. And so you basically go and say, I want an RDS instance. I want a database. Doesn't mean you're getting a database. You're getting a database infrastructure, so to speak, and you can actually put databases in that. But we're using Postgres today. We find that works well, across all of our solutions. Keeps costs down. We got Microsoft SQL comes with some licensing. So, other questions? So there are lots of other services we use. We wanted to highlight some of the cool ones. We use Route 53 for DNS. We use S3 for file storage. Amazon has a file storage capability. We use CloudFront for basically serving our web applications. Elastic load balancing is a capability. They got built-in load balancing, so we don't need hardware for that. We use there's volumes of storage, EFS like an NFS. There's EBS for block level storage. So AWS has a ton of stuff, and then that's just scraping the surface. They have machine learning capabilities. They have, collaboration capabilities. It's just the sky's the limit. But we wanted to highlight some of our main capabilities that we're using in AWS, and just kind of showcase those here. So I'm going to end with some of what's coming from GeoComm as it relates to SCSU. And maybe you've seen this, but coming at the end of, I can almost say this month, it's this month tomorrow. So the end of October is the Huskies Hackathon. We're one of the 3 sponsors. We're super excited to be participating in that. So we'll be bringing a really cool project and innovation to have the students, try to solve and get judged on. So we're really excited about that. We do a lot of innovation at GeoComm. We got crazy cool problems around GIS and public safety, Internet of Things type stuff. So that'll be a lot of fun. I'm hoping I see a lot of you there. Summer internships, they'll start May 2021. Sorry, I got 21 in the brain. They'll start coming up in May. Start looking for that in your, as you go to career fairs. GeoComm's at a lot of the career fairs, and you can get more information about our internships. I think Prashul was an intern at GeoComm, and if you want to ask him how it was, you can always hit him up for some of that, if it was how his experience was. And the final thing I wanted to, was there a question?
No, it's just about ask how was my experience. I was about to answer that.
Oh, okay. and the final thing I want to share is we're at career fairs. We come on and the site or we do virtual resume reviews, mock interviews. I think last week, Renee from GeoComm was doing mock interviews with people. So we're involved with the college and with the university, and we always entertain. If anyone ever has questions, or they can always reach out. So with that, I'll just kind of close it out with any questions or feedback. Happy to answer.
Any questions from you? No.
Yeah. So as an AWS partner, do you have to keep a certain amount of certified employees?
We do. Yeah, I did hear that one. Don't need to. So yeah, Chris is certified. Chris is a certified architect associate, and he has to renew every 2 years. We have 2 other individuals at GeoComm who have AWS certifications. And then I think we needed 2 people to be certified to have partner status. So for us to maintain that, we had to sell a certain amount, actually consume AWS compute and storage and all that stuff I talked about earlier at a certain dollar amount, which usually equates to sales for AWS. And then we had to have customer references and a few other things to jump through to become a public sector partner.
And
Yeah.
so going off a little bit from that, how much would you value a prospective hire if they had a certification already?
On AWS, if you were coming into a software development position, say you were an associate software engineer position at GeoComm, and you had a AWS developer associate, which I think would be a good fit for that. Yeah, that goes a long way, especially if you were joining a team that was building a product. Would I expect people to have that, or a student to have that coming right out of college? Probably not, but I think it's got some high value. When you're getting out in the industry looking for that next career opportunity.
Just a follow up on that question. Since you require AWS certified people to be on the team to use AWS, so do you help new hires be certified, or is it totally by themselves that they need to be certified with AWS?
Oh yeah, good question for sure. Yeah, we actually typically we'll pay for testing and training that's needed. Provide that opportunity. We really leverage Udemy, which is a great, not to give a sales pitch for Udemy, but it's a great tool for learning a lot of the tech skills. There's all kinds of other stuff on it, but that's pretty good. I don't know, Chris, do you have any feedback on, you went through that track, you just kind of busted it out.
Yeah. I did use Udemy. They have, if you're going for let's say the AWS developer certification, they'll have a course on Udemy for that. So it'd be multiple, classes, videos for different topics that's going to be covered in the certification exam. And that's kind of the process I went through when I went through a Udemy course. And then, I'd watch some videos, and if I didn't really understand something, I would be in AWS trying things out or just trying to understand it. So it definitely takes time. I mean, it took me, 2 months total hours, maybe. I was trying to track my hours. I maybe spent 50, 60 hours times, of time to study. So they're not fluffy tests. I mean, you really do have to kind of know, you got to take the time to really learn, which is good because it forces you to learn areas that maybe you wouldn't have otherwise spent the time on. So yeah, it's definitely a good thing.
And to the, Chris had brought up to that point of going out on AWS. I believe it's still the case. I haven't done it recently, but you can go out and sign up for a 1 year, no cost, account. After that, it's minimal. I mean, a lot of the services are pretty cheap. And if you're using micro environments or the smallest, you probably would spend $15 a month, maybe at a maximum, to have after that 1 year to have an AWS account to play in. So, and that if you're at all interested in AWS or this is something you're passionate about, definitely go and create an account and just start playing around in there.
Do we have any questions from people on Zoom? I'll take that as a no.
Definitely get your questions in there if you have any. Definitely a good chance to take advantage of that. I have a question. So as people are working on whether it's personal projects or a project for the hackathon or maybe a project for school where they have some of an open-ended project, you know, they have to kind of look through AWS or other things and identify what's going to be useful to them, what's going to be helpful. Do you have any advice for kind of sifting through the thousands of services they could use? Because you guys obviously settled on AWS, and you know we talked about a few specific ones today. But do you have any advice for that process?
I would start potentially looking at an online course that walks you through a project. So let's say you want to learn like front-end development. So like a Udemy or Linux Academy or Pluralsight, and go to one of those and look for a project-based scenario just to noodle on. And if you find one that says, you know, doing front-end development and using AWS, right? And now you could actually get some focused, again, Chris said it, pushed in some areas that you may not have thought to go. And then you can dive into services if it's an AWS, or you can dive into even development ways of using things that you never would have done, you know, if you've done some kind of self-paced scenario. Did that answer your question?
Yeah, I think that helps. So kind of looking for resources that are going to help you, you know, learn whatever you're looking at, and going with services that have that support is kind
yeah.
of.
I mean, I would say if you're passionate, let's say you're passionate about data analytics, right? So you go out and you find an online training about data analytics using AWS, and it probably is a project that tells you what services to set up, tells you how to integrate with those, and then it just walks you through step by step using AWS for data analytics. It's just one example. So, or maybe like building your own website on AWS, right? You're gonna, and it's gonna tell you what services to use versus you trying to go, what do I need for my web server, or what do I need for my database?
Okay, yeah.
Yeah, and just to add to that, the services that Ryan you know, showed here today, those are some of the key serverless type services in AWS, and they're growing extremely fast. Lambdas is, I believe I heard, is the fastest growing service in AWS. It's here, and it's going to be used more and more. So also one advantage of serverless, if you are interested in just trying certain things out quickly, and you're not going to be able to spend weeks on it, all those services that we talked about today, specifically Lambda, would be an easy one to go get a free AWS account. You can actually type your code right in the AWS console. They give you like a web dashboard to all this, just to do some very, very simple things and see it run. So if you're looking to just explore that, I think those are great services because you can get up and running with real simple prototypes to get a feel for it quickly.
Awesome.
Any other questions? You got us for 5 more minutes if you want to just, even if it's not related to AWS, you're just curious about just software development or software engineering in general, happy to answer them.
Yeah.
I'm wondering how all these strategies are built.
So the question is, how did you personally get started with software development?
Oh, that's great. Me personally, I didn't grow up in project-based development. I started out in IT networking. got into IT leadership, eventually started leading software development teams, and just completed a master's last year in software engineering to kind of round out my weak spots. So I'll tell you though, when I was like 11 or 12 years old, I had a old computer, and I would go to the library and grab Popular Mechanics magazines, and I would rewrite the code. It was like basic code, and make games. They were just like, choose your own adventure text games, but that was really fun for me. And to think, I don't know, 27 years later, I could, still be doing that kind of stuff, but I don't do it every day. But it's just, that's how I got started.
That's awesome.
Chris?
Yeah. So I probably got started maybe in my high school days. We didn't have programming courses back then, but we did have Excel, Microsoft Excel, and I started making macros and stuff. And I was like, man, this is fun. It was like magic seeing what you could do so quickly with code. And that kind of piqued my interest. And then came from a family run business. My dad had a business and he needed some automation and some data. And so I started using Microsoft Access. That was another popular program back in the day where you could basically just put forms over data, right? So data entry type forms, but then you can click a button, you can run Visual Basic code to do certain things. So then I started getting into Visual Basic, and I really enjoyed it. And then when I went to St. Cloud State, I was like, yeah, I'm going for computer science because, I was always amazed by how you can write code and just see how quickly a computer can process and make decisions. So I was hooked. I still enjoy it today. I still write code, not as much as I used to, but I still do.
That's awesome.
Yeah, good question. Thank you.
To close this, thank you so much, Ryan, Chris, for coming, joining us, and sharing your insights on AWS. I hope it was helpful for our students as well. So yeah, looking forward, just register for the hackathon. GeoComm's our major sponsor, and they'll have interesting, challenging problem. Do you have anything to add?
No, just one quick last question. As far as the internships and potentially jobs, what are you looking for this coming summer?
So yeah, summer 21, we'll be having 2 internship positions open in software development. They're software development interns. Those positions typically run from mid-May to the end of August. We align those team members, or those interns, with team members and put them on software development teams. So we're looking for people who've done some project-based development. Maybe they've had some experience working in a development project. And we typically are developing in JavaScript, C#.NET, as Chris mentioned, and Python. So some of those program language skills, some experience with Git is always a plus. Understanding, committing code and how that whole continuous integration works. And then related to jobs, we don't have any open software engineering positions. We do have a tech specialist position for supporting some of our technology. But from time to time, we do open up associate engineer positions. So.
Awesome. Well, again, thank you so much for coming out. Thank you everyone for joining us today. I hope you were able to learn more about AWS as well as GeoComm.
We have a hearty thank you from Dr. Anda, is our faculty advisor, and also a member of the CSCI department. So thank you so much, Mike, Chris.
Yeah. Thank you guys for hosting us. And we so appreciate you letting us come in and share a little bit. Have a great rest of your day, and hope to see you at the hackathon or somewhere around campus.
Thank you so much.
All right, we'll see you.
Bye, everybody.
Thanks.
Thanks.